Hi everyone. Today, this short video is going to be adding or subtracting fractions. Some of us freak out fractions. I don't want to work with fractions. Fractions are not that difficult if the basic understanding is there that when I have fractions, they're partials of a whole, or you can have improper fractions that are wholes plus partials. But if I just again look at two circles, and let's break them up into fractional parts. So if I have this broken down into a half and these into fourths, my denominator is 2 total parts. This one's 4. So I have these as my total parts, my denominator, and I want to add pieces together from both of them. Well, I have these big pieces here and I have smaller pieces here. I can't add them together because they're different size pieces. So if one of these I talk about, that's 1/4 of that. If I talk one of these pieces, it's 1/2 of those because it's one piece, the numerator. So how do I add those up then? Say I want to take one of these, and I'm going to say that's 1/2, and I want to use one of these, so that's 1/4, and I want to bring them together. I want to add them together. So subtraction works the same way. So as I'm talking about adding, subtracting works the same way. And so when I'm adding a fraction or subtracting it, I got to have my total parts the same. It's the only way I can add these because this guy's bigger than that part, and I can't bring them together until I have the equivalency of total parts. So how do we do that is that two methods. The first one is, can I find one of the fractional denominators the same as the other fractional denominator and go that route? Well, in this case, is 2 a factor of 4? Yes. So if I multiply 2 over 2, which is 1, and 1 does not change the value of a number from those math rules, and so if I do this, I can get 2/4. Now that 2/4 and that 1/4 have the same parts. Remember, if you watched my other video on the beginnings of understanding fractions, I could put that line through there. Now do I have my parts the same in both circles? Yes, I do. The 2/4 becomes here, 2 parts of the 4 now, and this 1 part. Now they're the same parts. I can add them together. The denominators are still the total of 4 parts, but then I can add the numerator parts, 1, 2, 3. And so I have a total of 3/4 that I'm talking about of a circle when I add the same size sectors or parts. So I was able to do that when I got the denominators the same or the total parts the same of both wholes. That is very important when I add and subtract. I cannot do the adding or subtracting until I get that common denominator is what we call that. So let's take it another way. If I have this 1/2 plus 1/4, and I'm doing very simple fractions just so we can see it works. And the other method that every addition or subtraction fraction works with is if I simply multiply the two denominators together. I don't have to look for a common factor in either one. I just can multiply them together because now, because I multiply this number times this number, they're two factors, so they're both in the same number. And that's what a denominator has to be. It has to be that part of another number. It's multiple. The multiples have to be parts of the factors have to be parts of the multiples. I'll get it spit out here quickly and say it the right way. So if these two are factors of a multiple, that is a common denominator then. So what is 2 times 4? 8. And that is my common denominator that I can use now. So what would that have been like? Well, that's saying I'm going to cut this into 8 parts, which I can do. And now I just made 8 pieces of each whole because that's in common with both of them. So then how do I do the numerators? Well, it's going back to a very simple way of understanding. What did I multiply 2 by to get this 8? 4. So if I just cross over diagonally and multiply these two, I've got my numerator of equivalency. So 4 times 1 is 4. And always bring down your sign, which is adding. And then cross over this way. 2 times 1 is 2. And I've just got two equivalent fractions to add together. Look at this guy. 4/8. 1, 2, 3, 4 parts. That's 4/8. 4 out of 8. And this guy, what's it? Oh, 2 parts out of 8. I have the total parts that I can add together because all the pieces are the same size now. And I got 2 over here and I have 4 over here. I add those numerators together and I get 6/8. 1, 2, 3, 4, 5, 6. 6 out of 8. Now the one thing that I stress is 6/8 in simplest form. And because we said before we added up the 1/4 and the 2/4 got me 3/4, is 3/4 the same as 6/8? Because that sounds like two different answers. But it is the same because they're equivalent. So this 6/8 can be reduced, and you should always try to do that, or simplify it is a better way to say it. So 6/8 was my answer to this method of adding or subtracting. We'll do a subtraction here too. But 6/8, if I divide out, because they're both even, that's one thing you should always look for reducing or simplifying fractions. Are they both even numbers? If so, you can take a 2 out or put them in half is another way of looking at it. So 6 divided by 2 is 3. 8 divided by 2 is 4. There's my 3/4 that we had earlier. And remember, always has to be the same on top and bottom of dividing or multiplying because value of 1 doesn't change your value of your answer. So 3/4 is 6/8. 6/8 is not totally wrong by adding those numbers the way we did it with that method, but it's a better answer to simplify it to 3/4. So let's try one subtraction here quick. And let's say we're going to subtract 3/4, or I should say 1/2 from 3/4. We're going to subtract those two fractions. And again, we would say, okay, is 2 a factor of 4? Yep. So I could say I've got 3/4 of a circle, and if I can get rid of some of these lines here now. So I have 3/4 of this circle, and if I go back to this guy and say I'm going to subtract this half of that circle, what am I going to end up with? Well, again, I cannot take that part or these parts and subtract that part because it's way too big compared to these, because I should get rid of this line so it looks like one piece. But I have 3 pieces here. 1, 2, 3 of 4, and I only have 1 of 2. Not the same size. So I can again say, oh, 1/2. That is multiplied by 2 over 2, and I can get 2/4 again. Oh, now my parts are the same. So again, divide that into 4 parts. Now I have all my parts the same, 4s. And now I can go 3 minus 2, numerator minus numerator. How many parts do I have I'm talking about? 1 of them. So my answer is 1/4. So if I took 2 of these away, I ended up with 1 of those. And so that is another way of looking at subtracting fractions. But will it work again with that other method? If I have 3/4 minus 1/2, what did we say to do? Multiply those together. 4 times 2 is 8. And then cross over. 2 times 3 is 6. Remember the sign. Don't forget that sign. Goes with that numerator. 4 times 1 is 4. 6 minus 4 is 2. 8. Always the same denominator. Is 2/8 the same as 1/4? That's where that simplifying should come into play. That is not a wrong answer. That is the correct answer, 2/8. But it's better if I can simplify fractions in their final look. So yes, I can divide out by 2 to both of these and get that down to 1/4. So same answer again, different method. For some students, some people can do this quickly and get that answer. You don't have to worry about finding those factors that are the same. So I knew that 2 is a factor of 4. Now I can make that 4ths. That works great. If math sense is what I call it, is easy for you and you see that, hey, super. What does that save you? The simplifying or reducing a fraction at the end. But 2/8 is the same answer as 1/4. It's just a better answer if you simplify. So that's adding and subtracting fractions. A quick lesson, quick review, I hope, because always learn it, hopefully, in the classroom, but these videos can be just a supplement of understanding it a little bit better. Thank you for watching, and go fractions.